Machine learning is a fascinating and powerful field of artificial intelligence. At its core, it involves teaching computers to learn from data and make decisions or predictions without being explicitly programmed for every single task. Imagine teaching a child to distinguish between different types of fruits. You show them apples, oranges, and bananas, and over time they learn to identify each fruit based on its characteristics like shape, color, and size. Machine learning works in a similar way. Instead of teaching a child, you're teaching a computer. In machine learning, the fruit is the data that we feed into the computer. This data can be anything: numbers, images, text, or even sounds. The computer, through algorithms, learns to recognize patterns and features in this data. For example, it might learn to differentiate between emails that are spam and those that are not. Or it might learn to predict which movies you'll enjoy based on your past viewing history. What makes machine learning so special is its ability to learn and improve over time. As it processes more data, its predictions and decisions get more accurate. This learning process is not hard-coded by a programmer. It's developed by the computer itself as it gains more experience from the data it's fed. Machine learning has three main types: supervised learning, where the computer is trained on labeled data; unsupervised learning, where the data is unlabeled and the computer has to find patterns on its own; and reinforcement learning, where the computer learns by trial and error using feedback to make better decisions. From powering recommendations on streaming services to helping self-driving cars navigate, machine learning is an integral part of many technologies we use daily. It's an ever-evolving field that continues to push the boundaries of what machines can learn and accomplish. Supervised learning. Supervised learning is like having a teacher guiding the learning process. Here, the machine is trained using a data set that is already labeled. This means the data comes with answers, like a student learning with the help of a key or solution manual. For instance, if you're teaching the machine to distinguish between emails that are spam and those that are not, you provide it with a bunch of emails which are already marked as spam or not spam. The machine uses this information to learn and make predictions on new, unseen emails. It's widely used for classification, categorizing data into predefined classes, and regression, predicting continuous values problems. Examples include predicting house prices based on various features or classifying images into different categories. Unsupervised learning. Unsupervised learning, in contrast, is like leaving the student without a guide. The data here is not labeled, which means the machine must figure out patterns and relationships on its own. It's like giving it a pile of fruits and asking it to sort them without knowing what each fruit is. Unsupervised learning is often used for clustering, grouping similar data points, and association, discovering rules that describe portions of the data. For example, it can be used to group customers based on their purchasing behavior for market segmentation, or to find associations between different products purchased together in a store. Reinforcement learning. Reinforcement learning is a more dynamic process, akin to training a pet with rewards and punishments. The machine learns to make decisions by performing actions and receiving feedback on those actions. The feedback is in terms of rewards or penalties. This type of learning is much like trial and error. The machine keeps adjusting its actions based on the rewards it gets. It's particularly useful for problems where the machine has to make a sequence of decisions and the outcome is not immediate but delayed. For example, it's used in training robots to walk or in developing algorithms for playing games like chess or Go, where the AI learns the best moves by playing numerous games and learning from wins and losses.